video, I'm going to show you one more diagram to help you understand the idea of a z-score before we move ahead to calculating z-scores. And what I'm showing you on this thing on this screen is just imaginary. I just made up these numbers. We're imagining that there's three populations, and all three populations have a mean average age of 40. The populations have different standard deviations. We're imagining population 1 has a standard deviation of 5, population 2 has a standard deviation of 10, and population 3 has a standard earlier. This means that in population 1, it's typical or average for a person to be 5 from the mean. In population or average to see a person 15 off from the mean. I explained that that's what the standard deviation tells you a couple of videos back. And since the populations have different standard deviations, they have different amounts of dispersion. So in this first population, the population members are pretty close together. And in population 2, they're spread out over a wider range. And in population 3, they're spread out even more widely. So now let me explain what the z-score is in each of these situations, starting with population 1. So in any population or in any data set, the mean has a z-score of 0. So since this first population has a mean of 40, in this first population, a 40-year-old has a z-score of 0 because they're right at the mean. Like I said, the mean always has a z-score of 0, no matter what. And if you go up, well, if you take the standard deviation of 5 and you go up by 5 from the mean, you get to a person who has a z-score of +1. So in this population, a person who's 5 above the mean would have a z-score of +1. A 45-year-old would have a z-score of +1 in this population. If you start at the mean and go down by 5 by the standard deviation, you get to a person with a z-score of -1. So in this population, a 35-year-old would have a z-score of -1. And if you start at 45 and you go up by 5 again, you'll see that a 50-year-old has a z-score of +2. Population has a z-score of -2. So I mentioned in the last video that the z-score of a value is the number of standard deviations that value falls from the mean. So in this population, 50 is 2 standard deviations above the mean, so it has a z-score of +2. Because if you start at the mean and you go up by the standard deviation, and you go up by the standard deviation again, in 2 steps, you get to 50, and that's 2 standard deviations above the mean, and it's +2. -2 is 2 standard deviations below the mean, so if you start at 40 and you go down a standard deviation, and you go down 1 more standard deviation, in 2 steps, you get to -2, which is 2 standard deviations below the mean. Now let's go to population 2. We're imagining population 2 has a mean age of 40, but a standard deviation of 10. Well, in this population, a 40-year-old would have a z-score of 0 because they're at the mean of their population, their average. And if you go up by 10, you're 1 standard deviation above the mean, and that age is +1. And if you start at 40 and go down by 10, you're 1 standard deviation below the mean, and you're at -1. So in this population, a 30-year-old would have a z-score of -1, and a 50-year-old would have a z-score of +1, because we're going in steps of 10 instead of steps of 5. And you're at +2, a 60-year-old, and if you start at 30 and go down by 10, you're at -2, which would be a 20-year-old in this population. And we're going in steps of 10 because the standard deviation is 10 in this population. Now, in population 3, we have a mean of 40 and a standard deviation of 15. Well, now we're going to be going in steps of 15. So once again, the mean has a z-score of 0. A 40-year-old would still be at 0. If you go up by 15, a 55-year-old has a z-score of +1. If you start at 40 and go down by 15, you get to -1, and it's a 25-year-old in this case. If you start at 55 and go up by 15 again, you'll get to the age of 70, which is +2 in this population. And if you start at 25 and go down by another 15, you get to 10, which is -2 in this population. So in any population, the mean has a z-score of 0, and all values above the mean have positive z-scores, and all values below the mean have negative z-scores. And the z-score is just going in steps of the standard deviation. Whatever the standard deviation happens to equal, you go in steps of that number. And hopefully this helps you get started with understanding the idea of a z-score, and so we can build on this understanding as we go forward, and you start to see more examples of involving and making your own diagrams of z-scores.